Good morning, everybody. I assume it's still morning. Maybe we have some people that are past the Eastern time zone in afternoon, but pleasure to be with you. I'm starting to get used to these virtual conferences where I talk into my camera and I don't see anybody in the audience. It's a little difficult for me because I'm more of a people person, but we'll make through. Eric did a great intro today, and you're going to probably see some overlap with some things. And Jerica, thank you for your presentation as well, because I think they all blend together. I'd like to talk a little bit about where I've been engaged in my career a lot with offshore and just energy production from offshore. It's a fascinating field. It offers a variety of different avenues for people to be engaged. From all of the engineering sciences. But the other thing I'd like to say is STEM is also very relevant to what I would call, and what we at Kiewit call, are the skilled trades. The men and women who are out there actually putting the things together that you see on my screen. Maybe they aren't all going to go and receive a degree in thermodynamics from a prestigious university, but there's still an awful lot of what I'd call technology involved in the trades to make all this happen. So quickly about Kiewit, for those of you who don't know, we are, I'd say, just a large Fortune 500 company engaged across a wide range of markets in the engineering and construction environment. We're a privately held company. We're, as I mentioned, in a lot of different markets, from transportation, highway, heavy civil, to my area, which is energy, and that includes power, oil and gas. We're also engaged in water, wastewater, and a little bit in mining. So Offshore Platform 101 is going to be the presentation today. We're going to walk you through kind of what is involved in offshore platforms, talk a little bit about maybe some of the career paths that you can get engaged with in this area. Building upon what Eric said earlier, and I think he showed some pictures of that, the first offshore platform, he mentioned the one with Kerr-McGee, and everybody gets a little technical there. Kerr-McGee built the one that was out of sight from land. So there was actually an offshore platform in 37, and you can see, the land nearby. But they were extracting the resources that he talked about, drilling wells. Instead of just doing it from land, it moved out into the water and made a lot more technical challenges when you get out there. You can see in the next picture, some of these fixed platforms started to get bigger. They would go further and further from shore and needed a bigger foundation to hold up all of the structures. Eventually, we got in such deep waters that we had to move to floating type installations. And Jerica even mentioned this is the same case for offshore wind. Some of these are what we call bottom founded structures, and others are designed to float so they can capture the resource, be it oil and gas, be it wind, or other renewable energy source in deeper locations. The components are pretty much the same. You have, in our vernacular, a topsides or deck, a support structure. In this picture, it's a jacket. If we get deeper and make it float, they have different names. So that's all. And then everything is anchored to the seabed. So you can see just in the scope of these, the topsides, you're going to have, that's where a lot of the energy is produced or conditioned. So as Eric talked about generating that oil and gas from the wellbore up to the topsides, there before you can put it in a pipeline and ship it, you have to clean it up a little bit. You have to make it stable so that the oil and gas can flow in a pipeline and do so safely. A lot of times that initial production involves all kinds of different career choices. Chemical engineers get involved, mechanical engineering with the pumps and the pressure vessels and heat exchange, obviously structural and civil engineering, designing the structure to hold it up. A lot of different careers there. And these installations, especially when they're offshore, have to be self-sustainable. So they have to generate their own power. They have to have accommodations for people to live and a place to cook. So these are almost like little mini cities that get put out into the ocean. And it's quite fascinating and quite a lot of different jobs that go along with it. In the foundations, there's geotechnical, geosciences. I know Eric talked about doing the sonar. Here we'll drill into the ground and examine what the soil looks like so that we can design piles or anchors or everything else to hold this in place. Because as you could see, this jacket has to withstand, as we just went through here in the Gulf of Mexico, hurricane forces. So very large waves, very large wind. And Jerica could probably talk a lot about just how do you analyze and withstand some of those large structures. Here's a closer up, non-cartoon picture of what these facilities look like. Fixed jackets, it's obviously the foundation for the topsides. It holds everything else up. It also supports the wells. In the case of oil and gas, it's the area that you drill and go into the ground and get the hydrocarbon resources. These same types of structures are also used for the offshore wind turbines that Jerica talked about. So here's an opportunity where our industry in the US has a lot of experience in building structures and putting them in the ground and maintaining them for what was a energy source from oil and gas and is now being utilized and transferred into renewable energy sources such as offshore wind. The topsides you see on the right contains all of what I'd call the processing equipment, the control rooms, and then, as I mentioned, living and accommodations and everything that goes along with keeping people out there to run this city. Some of the neat advances, and talk about just how technology's advanced, there's obviously a higher cost of having people live and work offshore. It also puts them at, while they're safe operations, it does put them into a little bit more of a higher risk occupation. With technology advancement, the virtual reality that was discussed earlier, simulators, various digital technologies that have merged, our industry has been extremely innovative in figuring out ways to automate the control and automate the process. So we're able to actually, while sitting onshore in a commercial building, monitor, control, and safely start up, shut down, and change the operating conditions of these oil and gas facilities offshore. So a lot of technology is continuing to advance. This is just an example of some of the technology that goes into play here. And I know Eric showed a wind turbine that was as tall as the Eiffel Tower. Here's a structure that Kiewit was actually part of building that's very, very tall. It's called a compliant tower. And it just goes to show you that of some of the highly technical, advanced, in this case, structural design fields that go into producing oil and gas. I mentioned as we got deeper and deeper, we couldn't just put a structure that sits on the bottom. We had to have things that float and then anchor them to the bottom, just like ships. So here's a couple of examples of different facilities that are utilized into oil and gas production that are floating. Again, a lot of technology. You have additional fields like naval architectures, even the technology in producing the hydrocarbons. The seabed, when you get very deep, is really, really cold. And so there's a lot of chemistry that goes into a term called flow assurance, what do we need to do now that we've produced oil and stabilized it so it's safe to transport? Now we got to get it somewhere. We got to get it on land where it can be further processed into gasoline for your car or other byproducts. And if that seabed is too cold, it could actually coagulate. It could kind of freeze up. Natural gas contains elements of water, so then you have hydrates that form. So there's a lot of science, even though this just looks like a big piece of iron and steel floating. There's a lot of science that goes into making sure that everything fits and everything goes together. FPSOs are another example of just a different shape of a ship. And they have different hydrodynamic properties used in different locations. The good thing about FPSOs, and I was working on a project where we're in a very harsh environment, sometimes you need to actually remove that asset from the field to get it out of harm's way, be that a very big storm, a hurricane, or in the case of the project I was talking about, icebergs. This one was up in the northern Canada area where icebergs are present. And I think with the Titanic, we all know what happens when an iceberg hits a ship. It's not good. The other interesting thing as we've gotten deeper and deeper waters is the advent of subsea production and subsea wells. And if you think about this, this is equivalent to like NASA technology. You're in an environment thousands of feet below water where no human can just walk out, turn a wrench, and attach a cable or attach a pipe. So it's almost like outer space without leaving the Earth. And a lot of companies have really innovated about how to design, how to install this equipment. You see a little contraption here on the left side of the screen called a remote operating vehicle. So the robots that Jerica was talking about designing, these are ROVs with manipulative arms that we can deploy under the water, controlled from the ship, and make connections and do minor repairs and other types of activity. So the field of oil and gas has really brought along a lot of technology, a lot of innovation, and it's been, I know, really exciting for me. So to close out, I was going to show you some pictures of just the construction. And I started off talking about how skilled trades are very important for this industry. We see that a lot in Kiewit and across the nation. There's, you know, some might say a shortage of people that are welders, electricians, machinists, carpenters. All of this is really vital to American infrastructure and keeping things moving and going. If your AC were to break later this week, I mean, you don't call your professor of thermodynamics to come fix it. It's usually somebody else. But there's still a lot of technology. Real quick, some examples of this jacket that we showed you pictures of. Obviously, I showed you a picture as it's all put together, but think about taking this tinker toy, if you will, of pieces that weigh literally tons and hundreds of tons each and trying to put it together. Orchestrating and planning that is quite an exercise and takes quite a bit of visualization, quite a bit of technologies, just even putting these things together. You can see that the topsides themselves, we kind of look at, okay, I can build, you know, these setup cans at the bottom, and then I'll come in here. How do you put these together? How does it all fit? And then planning, you know, and planning safely, I can build this level, I can put the equipment on it, I can float it together. And then I've got this whole big thing built. And for example, this structure that I'm showing probably weighs close to 9,000 tons. So that's an awful lot of weight. How do you move something like that? So just the science behind moving it onto a barge is called skidding. And so in this example, a jacket, you know, again, simple things like friction force and friction resistance, designing the loadout system to get it onto the barge. And then as you pull this massive weight onto something that's floating, obviously the barge is going to want to go further down into the water. So you've got ballast control, so you have ballast engineers and hydrodynamics going on. A lot of science behind what we do. Here's a quick picture of what looks like a skidding operation ready to put a large jacket onto a barge. Some close-ups. And then it goes and we transport this sucker. This is one that left our facility several years back, and it's quite an event for the local community. It's pretty impressive to see structures bigger than they've ever seen before just floating. And I think Jerica talked about that in one of her slides. I'm still amazed that some of this stuff floats. Like she said, airplanes landing on ships. And now we even have folks like Blue Origin and SpaceX landing rockets on moving ships. To me, it's fascinating. So we'll get these structures out, and believe it or not, we just kind of push them off the ship and let them float. They go up underwater, and then you hope you did all of your calculations right, and that even though this is a 1,000-ton steel structure, that it'll eventually come back up and float. And then we'll upright it, put it in its place, and then finally kind of crowning it like the candles on a birthday cake, put on the top sides and get into production. So I just think those actual photos of what we do are just truly impressive. The size, the scale, the amount of work and coordination that goes into what our industry does is in dire need of new students. So that's going to conclude